Hey guys, welcome to a new video. In today's video, we're going to look at a Leetcode problem, and the problem's name is minimum operations to exceed threshold value 2. In this question, we're given an integer array called nums, and we're also given an integer k. In one operation, we have to take the smallest two integers x and y present in the array nums. We have to remove those numbers x and y from the array nums. We have to add a new number anywhere inside the array using this formula. And we have to note that you can only apply the above operations if nums contains at least two elements inside the array. Because we have to remove two elements, you can't do this operation if there is only one element or if the array is empty. It should have at least two elements. Our final task is to return the minimum number of operations needed so that all the values present inside the array are greater than or equal to the value k, which is also given as input. Now let's take a look at this example and see how we can solve this question. I've taken the same example as example 1. We are given the nums array and the k value is 10. So all the elements at the end should be greater than or equal to 10. Now we know that we have to take the two smallest elements in every operation. So this gives you a hint that in every operation we have to pick the smallest element, so you can use a priority queue as a min heap. So let's store all the input array nums into the priority queue. So I'll create a priority queue. Let's iterate through the input array from starting to end. And this priority queue is going to contain long value data types because we have to multiply x and y value in every operation. So I take a priority queue and add the elements one by one and pick minimum values in every operation. So a priority queue necessarily does not store it in order, but in every operation it will give you the minimum value. For easier notation, I'm going to add it in ascending order. 1, 2, 3, 10 and 11. We have the PQ values. We'll iterate until priority queue dot size is greater than 1. So at least two elements should be present because it is mentioned in the note here. So this will be our while loop's exit condition, that until priority queue size is greater than 1, we will keep on performing the operations. In the first operation, we have to take x and y. X will be the minimum value 1. Using the poll method, x will be assigned to 1 and y will be assigned to 2. So these two will be removed and it will be assigned. Now before calculating the new element and adding it in the priority queue, we have to check that x should be less than k or y should be less than k. Only then we have to perform this operation, right? Because ultimately our task is to check all the elements are greater than or equal to k. There's no use of performing the new operation if these x or y values are greater than k. But in this case, this condition is satisfying. So let's calculate the new value. New value will be min of xy is 1 into 2 plus 2, which is equal to 4. And this value we had to add back into the priority queue. So I add it back into the priority queue and it will store it in min heap. So it will be stored like this. And finally our count, since we performed one operation, count will be incremented by 1, which will be our final output. Now count is 1. Now let's perform the operation because this value is still satisfied. Now x is 3 and y is 4. So these two values will be removed from the priority queue. Now let's calculate the new value. New value is equal to 3 into 2 plus 4, which is equal to 10. Add this 10 into the priority queue. Now we performed an operation, so increment count. Now we have to continue because this exit condition is satisfying. This value is 10. This value is 10. This condition is failing now, so there's no need to perform the new value operation. So whatever is present inside count value will be returned as the output, which is the expected output. Now let's take a look at the Java program. Coming to the function given to us, this is the function name. Parameters are an integer array and an integer k. And the return type is an integer representing the minimum number of operations. We have to take the smallest two values, right? So the first thing which comes into your mind, in each operation you have to get the minimum value. So you can use priority queue as a min heap. So let's declare the priority queue. And inside this, let's store our long variable because the value can be exceedingly long. So we have to store long variable. I'm naming it PQ. Now let's iterate through the input array nums given to us so that we can add those one by one into the priority queue. So into the priority queue, I use the offer method to add that element. So nums of I. Here we saw that priority queue accepts long. So let's convert this integer nums of I into long. Now we have all the elements in the priority queue. Let's declare our output variable. It is an integer. I'm going to name it count, which is initially 0. Now we have to iterate until the priority queue is not empty. And also a special note here that there should be at least two elements. So if pq dot size is greater than 1 only, we have to do the operations. If there is at least one element also, we have to script the while loop. Now let's implement these steps one by one. We have to take the smallest two elements. So we can use the poll method of the priority queue. The first element, I'm going to name it x. So from pq, let's take the smallest element and it will remove it also using the poll method. The next element is y. Again, we have to take the second smallest element after x is removed. So we have the two smallest elements. Now we have to add this third number, right? Only when x and y are less than k, right? So if x or y, so if x is less than k or y is less than k, we have to calculate the new element. The new element, I'm going to name it new val. And let's calculate that using the same operations, min of mat.min of x comma y, and we have to convert this into a long data type because we're storing it, and this will be multiplied by 2, and we have to add the mat.max of x comma y, and again we have to convert this into a long data type. Now we have a new variable. Let's add that into the priority queue. So I add this new val. And now since this is one operation, I increment the count variable. In the else block, it means x or y are greater than k, so we can't perform these operations using these x and y values, so we can directly break. And finally, outside this while loop, you can return the variable count, which will be a final answer. Just to make the code look clean, here we are removing x and y. We are checking if x or y are less than k. If this is skipped, these x and y are already removed from the priority queue, so we can add those back using the offered method. So I add x and y back into the priority queue. You can also ignore this, run the code. You see our test cases are successful, or you can also add these and run the code. The test cases are successful. Let's submit the code. And our solution is accepted. So time complexity of this approach is n.log n, where n is the length of the nums array, and the space complexity is also big of n because we're using a priority queue and storing all the elements of nums into the priority queue. That's it guys. Thank you for watching, and I'll see you in the next video.